In this media, you are going to learn about equipment failure patterns. A study of these patterns helps in deciding the maintenance requirements. Pattern A. It is known as the bathtub curve, and it shows an increased probability of failure at the initial and final stages of the equipment life. Pattern B. It is known as the wear-out curve, and such equipment displays low rate of random failures during the initial stage and a sudden increase at the end of its life. Pattern C. It is known as the fatigue curve, and it is a slowly elevating graph that shows increasing level of failures over the course of the life of the equipment. Pattern D. It is called initial break-in curve, which starts with a very low failure rate and is followed by a sudden hike to a steady level. Pattern E. It is named as random pattern, and it denotes sustained level of random failures throughout the equipment life. Pattern F. It is called infant mortality curve, which shows high failure rate at the initial stages and a sudden drop to a low steady level at the later stages. The percentages of random failure for these patterns A, B, C, D, E and F are 4%, 2%, 5%, 7%, 14% and 68% respectively. Analysis of the failure patterns. Patterns A, B and C indicate that the failure rates increase once the equipment reaches a certain age that is mentioned in time or usage hours. These three failure patterns are usually related to wear, erosion or corrosion and are often simple components. The other patterns D, E and F largely indicate that during the initial startup of the equipment, the majority of failures take place. This could be due to maintenance in the initial stages or due to manufacturing or material defects in the components. Once the initial startup period is over, the failure rate is usually random, and these patterns are applicable to a large number of failures. In cases of failures other than the above, the equipment needs to be monitored for its condition, and the findings of such monitoring shall indicate the right time to carry out a replacement or an overhauling exercise. This is known as condition-based maintenance or predictive maintenance. Thus, we have learned about equipment failure patterns.